Welcome back. Today we are rationalizing denominators with a focus on surds. And what I mean by rationalizing a denominator, essentially if you have a fraction situation and you have a surd underneath the line or as the denominator, that's not really the best way to work with, an expression. We don't want that there because it's difficult for us to divide with it. It's difficult for us to quantify what we're dealing with. So we rather not to have them there. And that's why we want to rationalize the denominator. So how do we do it? Essentially what you're going to do is you're going to multiply above and below by whatever is necessary to make that denominator rational. And in a lot of cases, we are using our difference of two squares knowledge here to help us with that. But we'll see examples of that as we go along. So the best way to do this and learn about this is to go straight in with a few examples. So first example here, we have 3 over the square root of 2. Now we know a square root of 2 is a surd. It's not going to give us a whole number answer, so technically it's irrational. What I'm going to do is I'm going to multiply above and below by the square root of 2. And the reason I do this is because I'm only multiplying that fraction by 1 in theory, because the square root over 2 over the square root of 2 is 1. So I'm not changing the value of the number, I'm like deliberately manipulating it. And when I multiply that out on the bottom there, you can see I get the square root of 2 squared, and we know that that reduces down to just a 2. So I've now made the bottom of that fraction. Moving on to example 2 there, I just added in an extra bit of information. So we have 5 over 3 root 7. Again, you know that root 7 is a surd. We cannot get a whole number answer. I'm going to multiply that by root 7 over root 7. Now, you could multiply it by 3 root 7 over 3 root 7, but there's no need because the 3 is a whole number. We're perfectly fine with that. And I follow the process. I multiply it out and I end up getting 5 root 7 over 21. Example 3 there, I did the exact same process. Moving on to question 4, however, there's a little bit more going on. And this is where a difference of two squares situation appear. So I'm going to multiply above and below by root 3 plus 4. Why do we do that? Again, we must ensure that with the multiplying out process that the surd gets eliminated. That's why we change the sign, and your rule of difference of two squares backs this up, and that's pretty much where we're getting this method from. Quite a bit of multiplying out to be done here. As I always say, don't feel under pressure to be doing it in 1 step or 2 steps. There's lots of people out there who make you feel under pressure to do that. Absolutely not. You take as many steps as you want. As the state examiner here, I don't really care if you do it in 2 steps or 20 steps. As long as you're doing it and you're showing me your work and you're getting it as correct as you possibly can, I'm good with that. We do not judge that it takes you 6 lines to get this done. Absolutely not. If anything, we can see your work better when you do it that way. So I'm multiplying out, but keep an eye on the denominator there, okay? That 4 root 3 minus 4 root 3 turns out to give me nothing. The root 3 squared turns into a 3, and the 16, the minus 16 there is just a whole number. So I get minus 13 on the bottom. Happy days. Now, bear in mind, sometimes you can't simplify down the top line as nicely as you would like, but sometimes that's just the way. Moving on to question 5 and question 6 here, we are doing the same thing. I'm showing several scenarios here just to make sure you see all the different versions. So in question 5, you have a minus surd. In question 6 there, you have a positive surd. That doesn't matter. You're changing that sign in the middle as per the difference of two squares method. So we have 1 minus root 3, 1 plus root 3. And on question 6, you'll have 3 minus root 5, 3 plus root 5. Again, that doesn't really matter. That's the way our difference of two squares will work. So again, loads and loads of multiplying out here. Just take your time, make sure you're multiplying everything out correctly. And your goal here is always to get a whole number on the denominator. And if that's not happening, you may have multiplied by the wrong thing at the start, or you may have made an error with your pluses, your minuses, or your surds, or something like that. So just go back and double check. But the goal here is to get that whole number in the denominator. Our last example here is probably one of the more difficult ones, where you've got actually two surds in the denominator, root 5 plus root 3. Again, we're sticking to our difference of two squares idea, where I want the same thing with different signs. So root 5 plus root 3, root 5 minus root 3, and I just follow that. Now, I'm not multiplying out the top line in this question because there is no good that comes from it. There's no cancelling out opportunities or reducing down. There's nothing. You just get a line of loads of different surds. So I actually didn't bother multiplying it. Not that I didn't bother, but you know what I mean. I didn't go through the hassle. So I worked on the bottom. We ended up getting a nice whole number of 2 on the end there as you work along. I have a worksheet on my website, Mrs. Maths Ireland, to go along with this. The link is below in the bio. Make sure you subscribe and send this to a friend who needs it. See you soon.